So hello everyone, welcome to ML project building series again. So today we will gonna be building a diabetes prediction model using machine learning. So let's begin. So first we are getting the steps that we'll gonna be follow to build that machine learning model. First what I'll gonna do, I'll gonna import the data, and after that I'll gonna be for the imported data I'll gonna be using the EDA, which means exploratory data analysis. It will help us to understand the data more precisely. Also, if is there any fault on that data, it will help us to extract that one. And after that what we're gonna do, we're gonna switch to feature extraction. The reason that I'll do feature extraction for that particular dataset, because all the feature is not needed for that particular dataset to feed onto the machine learning models. Some of the main features will be needed. So after the successful feature extraction, we're gonna be going to the pre-processing sector. For the pre-processing, I'll gonna be using some standard scalar or any other scaling, because our data set will have some different ranges. So I'll gonna keep all the values or data onto the similar range or same range. And after the successful pre-processing, we're gonna be switched to model building. During model building, I'll gonna feed all the pre-processing data to the model, and I'll gonna check the model is working or not. If the model is properly working and predicting the data or outcome properly, I'll gonna be going through the model building process, model comparison process. Here I added model comparison. It is not mandatory, it is optional. The reason why I added model comparison, because I'll gonna check other machine learning model that is available for categorical data also, because if there is a comparison, then I can check which model is giving us the best accuracy. Using that best accuracy model, we can also predict that same outcome. And let's go to the next step, next one. So for next we are getting the prediction. Like for prediction, the result will be coming, the outcome prediction. For outcome prediction, on the CSV file we are getting the outcome as 0 or 1. For 1 the patient is diabetic, but for 0 the patient is not diabetic. If the outcome, the predicted value is coming as 1, it means the patient is diabetic. But if our machine learning models gives the outcome as 0, it means the patient is not diabetic. So let's move to next. So on next we are getting the machine learning models mostly used for categorical dataset that we're gonna be using for this tutorial. So let's do ML model breakdown here. So first I'll be getting the logistic regression, which is the most commonly used machine learning model for for categorical dataset. After that we are getting the decision tree, and after the KNN, also known as k nearest neighbors. And after that we are having the support vector machine, also known as SVM. And on the last two I added here, it is not compulsory, like XGBoost and gradient boosting machines. These two are mostly used, these two are mostly from assembling model, like boosting models. The reason I added them, because those two are here to enhance the accuracy and the prediction of the particular machine learning model. So I'll gonna comparing all those to one to another and check which model is the giving the most highest accuracy. The most highest accuracy model, then I'll gonna pick that one and I'll gonna use that for prediction. So now here is the breakdown. Let's jump into our Jupyter notebook. So for this diabetes prediction model, we are using these 5 steps, like data import, EDA, feature extraction, model building, and model comparison. So first I'm gonna jump to Jupyter notebook, and as of now, for first time I imported these two library, numpy as np and pandas as pd. And after that I initialize the dataset on data variable and using the pd.read underscore csv pandas csv function. And after that I plotted using the head function. For head we are getting first 5 rows, and we have the column respectively. And for the columns we are getting the pregnancies, as this data set this data set is lies on the female people, and also we are getting glucose, blood pressure, skin thickness. And first of all, this skin thickness is coming from the triceps. All the body mass and body fat is coming over here. And after that we are heading towards insulin, BMI, diabetes pedigree function, which indicates some parameters on some index value of the diabetes. And after that we are getting the age and outcome. So for outcome, if it indicates 1, that means that the patient is diabetic, and if the outcome is 0, it indicates that patient is not diabetic. So right now what we can do over here, we can simply check the shape of our data set. I'm going to simply hit data dot shape. Sorry. So as you can see, 768 rows are there, and 9 columns are there for this data set. So if we do simply EDA step, like so if we check the data describe, we can see all those numerical values, indexes are coming, like for the describe, count, mean, standard, minimum, and some other values like 50%, 70%, or the maximum value. So what it did for each of the row that we are getting, it all those values are coming. For also each of the columns, the values for discrete function is coming, like 25%, 50%, maximum values, and all other values over here. So as you can see, if we see the count, the maximum number of count is coming, as there are 768 rows are there. So it indicates that 768 values are there. So mean, the mean of all the data, and minimum is the minimum value. For some rows it is coming 0.000, and for some rows it is coming something value, minimum value. And maximum value, also you can see 25% of value, 50% or 70% is also there. So what we're gonna do, without right now, we can check, like is there any fault in our data or not. Like we can do data, can check data is null, is there any null value or not. Sorry, it will be data. And as you can see, for first 5 row and last 5 row, all are coming as false. It's indicate that false indicate there is no null value for first 5 and second 5, but we don't for last 5, but we don't know about that in between, is there any null value lies or not. So what we're gonna do, we're gonna sum it up. And after summing, as you can see, all columns are coming 0 0 0 0. So we can be assured that there is no null value. So another trick is that if we call it again, the sum function, it is showing 0. So in total there is no null value. So after that, what we can do, another thing, we can check data.info. The reason I hit data.info is to check the other information. Like as you can see, the data type is categorized into two form. First is floating and another is integer. So there is no object form over here, so we don't need to convert anything, any string into numerical form, which is a good thing. And memory usage is getting 54 kilobyte, and total number of rows are 768. And for each of the columns, we are getting the total values, is there any null values or not, and the d types. So after that, if we want to check other things, like what you can check, data describe is there, info is there, shape is also there. So I think that will be enough for this data set to check. We can simply define define our x and y, separating the data. Let's separate the data. The reason why we are separating the data is to feed on to the machine learning model so it can predict in a good manner. So what we're gonna do, we also doing here a little bit feature extraction. This is called the all of the feature that we are selecting over here from overall the data set is going to the machine learning model. So now if we separate the data for x1 x we are getting the data, and what we're gonna do for x, we are mostly predicting just what we're gonna do, I'm gonna simply call the data again to describe what we are doing here. So here we're gonna be predicting the outcome. So what I'm gonna do here, I'm gonna simply drop the outcome for any of the x or y, and I'm gonna take all the values in another x or y. That will help us to separate the two data set, and for that we're gonna be predicting the outcome only using the correlation or other machine learning models. We're gonna be predicting this data set. So for here, as you can see, this outcome is coming on categorical like 0 1 0 1 0 and 1. All lies between in 0 and 1, which indicates the categorical. So mostly the categorical, the machine learning model that predicts the categorical values, we're gonna use those one only. So first of all, I'm gonna divide the data set. So here I'm gonna use data. I'm gonna drop the column. I'm gonna here use the outcome to drop it, and x will be 1. After that, for y, what we're gonna do, we're gonna pick the data again, and I'm gonna simply take the outcome only. Okay, like sorry, there will be columns, not column. So now it's working. So what we'll do here, I will gonna print x. As you can see on the x variable, the data set is defined without outcome. There is no outcome column over here. If we now, only 8 columns are here, before we got 9 columns, so one column is missing. So if we now print y, we can see only outcome is coming, outcome values like 0 1 0 1 0 1. So as of now, we can assume that our separating of data is complete. So another thing we need to see that for all of the values like pregnancies, glucose, blood pressure, skin thickness, all the values lies on different range. Like for pregnancies, we are getting 6 1 8 1 0 10 5 2 5 1 1. Like it's indicate between 0 to 10 maybe mostly. But on glucose we are getting on 100, like on 100, or after 50 or something. Blood pressure values also indicates on different dif- uh, different line, and also skin thickness and other insulin, BMI, everything is coming, the range is different. For all other things, age also, the range is different. So to avoid the errors or low prediction rate, what we're gonna do, we're gonna use the data standardization. We can use some standard scalar or something that will help us to indicate all our data in a separate or in a common range. So what I'm gonna do, I'm gonna first call here the standard scalar for the pre-processing. I'm gonna call import from sklearn. Pre-processing, I'm gonna import standard scalar. Okay, there is a syntax error, like pre-processing. simply I'm gonna simply check it again. Scanner, something called scanner. Okay, okay, there is a issue with the standard scanner, so I'm gonna simply paste it and see now it's working. So what we're gonna do, oh, let's import the other also for a fast process. So what we're gonna do, I'm gonna use from sklearn again, and use the model selection, and from model selection I'm gonna be importing the train test split, which is the training, testing and splitting uh, library. Train test and split. So right now we have also this one. So for this model, what I'm gonna do, I'm gonna use there is a categorical form, and I'm gonna be using from sklearn. I'm gonna call import support vector machine SVM. And after that, also to measure the accuracy, I need the metrics from metrics accuracy score. So sklearn metrics. So accuracy, it's done over here. Okay, like, okay, there is a issue over here, the metrics not matrices. Yes, it's working. So what we're gonna do now, I'll gonna, as I initialized the library, first one is coming as a pre-processing standard scalar, so I'll gonna be using that one for pre-processing. So I'm gonna hit over here and write data standardization, and for that one I'll gonna use the scalar, define it to scalar and standardization scalar. I'm gonna call this function, and after that what I'm gonna do again, I'm gonna use the scalar to and call it as a fit. I'll use the fit function to fit the data set. I'm gonna be giving here the x1 x over here, and I'm gonna see here as it is getting the data like fit for x, and for standardized data we're gonna use the uh, scalar dot transform over here. So simply write it. Okay, go one sec. Standardized, I'm going to define standardized data, and I'm going to be picking scalar dot transform, and from standard dot scalar dot transform we're going to be hitting same to same as x, and as you can see we defined that. So right now what we're going to do, I'm going to print it to see how our data is now looking like. As you can see, the data is coming to a particular range line, like before it was like somewhere between 148 6 something 72 39 and 0.6 to 7. It's different 50. But if we see the data, same data right now, it came to a particular range, like the nearest range, like for the 0.639 and something 0.84 something 0.14. So it all those are lying between 0 point something to 1 point something something. So which is a great thing to get the uh, um, most accuracy on the on during the prediction. So what I can do right now, I can simply take the x and initialize the same data or standardized data, and for y the same outcome I will gonna use. There is no different. So I again initialize that data, and for that what I'm gonna do right now, I'm gonna simply check over again print x. As you can see, the all those standardized data has come, and also for print y, let's check it again. Yeah, 0101 outcomes are coming. So now what I'm gonna do, I'm gonna train and test and split the data. Split the data. So for that, we're gonna take x train, x test, y train, and y test. Okay, for that we're gonna call train test split function, as we defined the libraries earlier on the uh, first chunk or the first cell. Inside the function we will be forwarding it to x and y that we defined, and for the test size we're gonna be giving it to 0.2, and for we're gonna use another thing like stratify. We're gonna use it. We're gonna give it to y, and for random state we're gonna give it to 2, value 2. Okay, let's check. Yeah, the data is now splitted, and went to like 3 4 things like train test split, and if we print over here like x train, as you can see the data is successfully divided into split. What we're gonna do right now, we're gonna train the model, over here. So for training the model we're gonna use the SVM classifier. So I'm gonna take classifier and initialize as to SVM dot support vector classifier SVC, and after that we're gonna use the kernel as linear, like on support vector classifier there is a kernel. If we google it, we can see on image. Sorry, another thing is coming. SVM. If we see the picture, there is a kernel is simply coming. So what this kernel do, for our prediction model, there is coming 0 and 1, right? Diabetic and non-diabetic. So this kernel is dividing the non uh, uh, on the prediction model, it is dividing the people who are non-diabetic as 0, for example 0, and diabetic, for example 1. This kernel on the classifier always helps to divide the data points that are doing the prediction. Like this is the perfect example, I think we can see. So this is our decision boundary. This is margin that is coming. For soft margin, hard margin is there. So if the line touches the minimum the margin, it showing the result. Also these also, like for the model we are getting not only 0 or 1, maybe near to 0 0.6, 0.7, something like that also. So it helps the kernel. As you can see, the kernel divides the data on the during the prediction, and define it will define our diabetic and non-diabetic 0 and 1 over here. So we're gonna go back to our prediction Jupyter notebook. So here I'll gonna simply run it, and after that I'll gonna fit it. I'll gonna simply copy it, paste, and use the fit function. And what I'll gonna fit here, I'll gonna fit the X train and Y train. Okay, so fit is working over here and kernel is coming to linear. And after that, what we can do, we can do model evaluation, like the model is predicted and the model is working or not. So here model evaluation is coming. So for that, like we can check for evaluation, we can check the accuracy score. We defined on the first as a library from matrix, we are getting the accuracy score over here. So I'm gonna be checking the accuracy score. So what we're gonna do over here, I'm gonna pick a prediction like X train predictor, and for that I'm gonna use the classifier and use the predict function, and I'm gonna simply initialize on X train. I'm gonna simply feed it to X train, and after that we can take ACC means accuracy. So accuracy score, we can take accuracy score function, and using that we can simply call this one X train predictor, and with X train predictor I'm gonna use the Y train. So what we can do here, we can print and check how much accuracy we are getting. See accuracy we getting, okay, sorry. So for accuracy we are getting, we can use the A double C, and as you can see we are getting 78%, like 0.7866, which is 78% 78.66 percentage accuracy we are getting, which is I think average enough to predict something from the from our data set, but honestly it is not great enough, like 78%. After we get anything, any value over 80%, that is fair enough, but 78 is also an average value that we are getting. So let's try with this model that it can be predictable or not. So what I can do here, I can lets me see the data again, call me the data again. So what we can do here, for example, we can take a data of any patient like this row, and initialize this to some numpy array, and all those array will be going to the machine learning model, and using that machine learning model, it will predict. If it predict zero, like this answer properly, that then we can decide this model is working properly or not. So let's make a predicting system, making a predict okay, making a predictive system over here. So what we're gonna do, I'll gonna use input data. I'm gonna leave this as blank. Sorry, it will be like this input underscore data, and I'm gonna simply leave this array as blank. Let me like the logic first. So what I'm gonna do, I'm gonna use it as convert it as a numpy array from simple one to numpy array. I'm gonna copy it and paste it over here. and from numpy array I am calling from numpy calling np dot as array, and I'll gonna be calling this initialize it over here. So what we'll gonna do, the values that we are giving over here, like for example 1 2 3 4 5, it will be converted into numpy array. So after that what we can do over here, we can reshape the data into 1:1. So input data reshape, and we're gonna use input data as, okay, there is no need, we're gonna reshape this one. Okay, so I'm gonna paste it over here, and I'm gonna use the reshape function, and I'm gonna define 1 and 1. So what we're gonna do, it will gonna use the 1 dimension, like a 1:1 array. So after that we can, as we use the standardized data over here for processing, we need to use it again, and reshape. If we use the reshape, uh, if we are using the standard data on the reshape, then the actual prediction will come, because our prediction model is already predicting the standardized data only, not from the direct data set, like all those value. It is predicting over here all those values like 0.250 something, this range. So what we're gonna do, I'm gonna call this that standard scalar again. So std data, std underscore data. What I'm gonna do here, I'm gonna call the scalar, and heat transform, and for that we can use this one, like reshaped, and for that we're gonna use we can print the standard value here, like standard data, and let's do a thing, let's check, like I'm giving 20 30 40 50. Okay, error is coming. So like float must be string and are not set. Okay, there is error coming over here. So if we check properly, okay, it will be not like that, like 20 30 40 50 for example we are giving, and right now we have okay, cannot reshape array of size 5 into shape 1 1. Okay, sorry, it will be -1. So here x has 5 feature, and but standard scalar is expecting 8 feature. Okay, we need to give 8 feature, like 60 70 80. Oh, now it's working. As you can see, now we gave a example data over here, and it is converting into numpy shape and reshape, and after that it is going to the standard data, and we are printing that standard scalar data. So it is coming like that. So what we can do over here, let's collect the first patient data over here, and let's check it is working or not. So what I'm gonna do, I'm gonna copy it over, simply copy it here and paste it. and as you can, we can need to adjust it as it is. Let's adjust those. So after adjusting, let's run it again. Some error is coming. Access 9 feature, but standard scalar is expecting 8 feature as input. Okay, 8 feature is no need to be input. Okay, sorry, we gave output. There should be no output over here. As you can see, it's now working. So what we'll do now, we'll use the we will do the prediction again, and for prediction gonna use scalar dot transform, and from the transform function we'll use the that input data reshape. Okay, input data reshape, and after that we're gonna print the prediction also. Just gonna check it again. We're gonna check. Scalar, okay, sorry. uh, okay, sorry, I wrote the wrong thing. Should be not scalar dot transform, it will be classify the dot predict, because we are using the prediction here. Now okay, now it's coming as 1, like it's also outcome is showing 1, which indicates that it is predicting perfectly. Now what we can do here, we can write a logic over here. If the prediction, if the prediction is lying between 0, it's coming 0, what we can tell over here, we can simply print the patient is not diabetic. It's not diabetic. Okay, so else if it is coming as like a 1, we'll print the patient is diabetic. So as we see here, the patient is diabetic. So for the first one, we took this patient values. For that one, the outcome, the actual outcome is also coming 1, as the patient is diabetic, and our prediction model is also giving us 1, which means the patient is diabetic. So as you from here, as you can tell, the our machine learning building process is successful, and it is giving us the successful predictions. So now let's go to the next step. So for next step, the model comparison will come. So for here, okay, so for here, if we want to do model comparison, uh, we can do like as I told earlier, I can use all other categorical machine learning models that is used on categorical data set. I can use those machine learning models. So previously I already wrote the codes for that for those model, because the video is going too much far long. So if I write all other things, they it will increase a little bit long. So I'm gonna simply paste all those things, and I'm gonna describe it was what is happening here. For here we took x and y as a small letter. What I did here, I imported the imported the necessary libraries over here, like the machine learning models that I am going to use, like random forest, decision tree, KNN, and we will be needing accuracy, and I'll be using the matplotlib plot here. And what I did here, I spread the dataset again. It is not mandatory here, but I did it here again. After that, we'll have to define the models. And here what I did, I took a model and initialized into the model as all the models I have called here. For logistic regression, I took max iteration as 1000, up to 1000 I took. And all other models is also coming, like decision tree. I called the function of decision tree classifier here. And random forest also same, SB, support vector classifier, k nearest neighbor, gradient boosting, and add a boost. And after that, we are I took a blank score. And for the each score, what I am doing, I am using a for loop to iterate between the models, and use the accuracy metrics. I'll gonna predict, and I'll gonna take the accuracy over here. So after that, what I did here, I'll gonna plot a bar plot from matplotlib, and I am giving some color values like blue, green, orange, and red, and x and y label are there respectively. And after that, what I did, I wrote for the bars, I wrote to show the accuracy over the height of the bottom. I wrote a for loop for each of the bar. And at last, what I'll gonna do, I'll gonna use the plt show. Now if we run, we can see that from all of the models, we are getting the highest accuracy of 75%. Previously, from SBM, we got a little bit higher, like 78%, which is nearly 78.66% accuracy. But all those all others algorithm gave us a low accuracy. So for here, the highest we are getting is 75%, which is providing us logistic regression and logistic regression and gradient boosting. And all other is not on, another is there, like a decision tree. And after that, the lowest we got is KNN, k nearest neighbor we got. So as you can see, our machine learning model is successfully built and done. Predicting is already giving. And we also did the model comparison. Using the model comparison, we can see which of the models are working perfectly. So to compare the, if we compare the percentage, we can tell that the SBM that we used previously, like we got 78.66%, that is giving us the highest accuracy. So for here today, I think it is done. Thank you everyone for being for such a long time.